Congratulations, you found the right video to get your homework done. This is your homework assignment for lesson 1-1. Very quick review of what your notebook is supposed to look like. It does not have to be graph paper, but it does have to be a bunch of papers all collected in a binder, in a folder, in a notebook, somehow. I expect you to be writing in pencil. If you grabbed a pen, go get a pencil right now, because it would really be awful if I made you redo your homework just because it was in pen. Please label the lesson in the left corner. Put the date in the right corner. I think I'm already off on the date. I think you're going to be doing this on September 4th, 2013. No big deal. The front cover of your book should have your name on it and Algebra 1, so that when it gets left somewhere, we can find it, get it back to you. And as you can see, your homework sheet needs to be inside the front cover of your book. Now, I'm going to tell you, the first time I recorded this lesson, you had about 45 minutes of homework tonight, and I decided that was way too much, so I'm going to cut this down, and we'll check in tomorrow and see how it goes. Your first step on homework almost every night is going to be vocabulary, but I do not always need you to write out definitions. This is math class after all. Giving me an example is often going to be sufficient. What I'd like you to do is write these words down: algebra, quantity, variable, algebraic expression, numerical expression, quotient, product. Don't do the definitions. We're about to do them on the next page. Poof, just like that. Because it's darker, I've switched to writing in pen. But as I said before, yours had better be in pencil. There's no definition of algebra in the first chapter of your book, which I thought was pretty silly. All algebra is math where symbols replace numbers. For example, 3x plus 2 equals y. That's all it means. If you're using a variable instead of just numbers, it's algebra. You've actually been doing this since about kindergarten, one way or another. Maybe you've used a box or something else instead of an x, but you've all been doing this for years. This is where I'm starting to cut things down. Originally, I wanted you to write this definition down. Now, I just want an example. And it's got to be different than mine. My example for quantity: the distance from your kitchen table to the bus. Anything that can be counted or measured. Next, a variable. A symbol that represents a changeable quantity. For example, y or x. Your examples could be other letters. In fact, they need to be other letters. Algebraic expression. A math problem with at least one variable. Don't worry about writing all that down. Just give me an example. Make one up. Mine is 2x equals 24. Yours will be something else. An algebraic expression is different from a numerical expression because a numerical expression has no variables. Like this one, 3 plus 16 equals 19. Don't worry about the words. Come up with an example. Quotient. For this, just write down answer when you divide. The answer to a division problem. Don't bother writing out this whole example because that's wordy. Same thing with product. The answer to a multiplication problem. Just write down the answer when you multiply. Here's a full example. You really don't need to write it all out. Given negative 5 times 6, the product is negative 30. So when we check your homework tomorrow, I expect you will have your own unique examples for algebra, quantity, variable, algebraic expression, numerical expression. Quotient and product, you will actually have some words written down. Pause the video if you need to. Finish that up. I'll wait. Now that you've got those definitions done, let's move on, get through the work in this chapter. In front of you, you see the main idea of I guess I should say section 1-1. You are translating word problems into algebra and algebra into word problems. That's all there is to it. Take a look, please, in your book at page 4. Problem 1. I'll zoom in on it. Writing expressions with addition and subtraction. They give you the word phrase here. 32 more than a number n. They give you the math over here. n plus 32. I kind of think this is why math was invented, because saying it this way strikes me as ridiculous. Another one, letter B. 58 less a number, n. And they just give you the math here, 58 minus n. That's all they're looking for. Can you go from here to here? Can you go from here to here? They have given you these visual models in the middle. If you like them and they make sense to you, that's lovely. If they don't make any sense to you, don't worry about it. Now, the next thing I want you to put in your homework book is the answer to got it, number 1. What is an algebraic expression for 18 more than a number n? So in other words, translate this into a math problem. In your book, I should see page 4. I should see number 1, and I should see your answer here, not a question mark. You get that done? I'll wait. Now we're on the top of page 5. Basically, they're doing the same things you just did with addition and subtraction, but they're using multiplication and division. They're giving you the fussy word phrase, 8 times a number n, and they give you this model, and the math is just 8 times n, which you can express any of those ways. They're all correct. I prefer actually this last way because it's clearest. The dot tends to look like a decimal point if you're not really clear, and x could be a variable. So this is my favorite, but they're all correct. They give you another example, letter B. The quotient of a number, n and 5, which I guess is why you need to know the definition of quotient so that you can write this out in English. I would just as soon write it out as math, n divided by 5 or n over 5. Again, you're going to find that this second one is an easier way to write it now that you're in algebra. So, next thing I want you to put in your homework book is the answers to got it number 2. What is an algebraic expression for each word phrase in A and B? Just write out the math for those two. Then they want you to do a little bit of thinking for letter C. Do the phrases 6 less a number y and 6 less than a number y mean the same thing? Think about it. You might take a look in your book and see if they say anything about it. And as you can see here, I'll zoom out so you actually can see. I want you to give me, in the book, write down page 5, number 2, label everything. Label A, put your answer here. Label B, put your answer here. And label C, it needs a sentence. Don't give me just one word. I need some thinking and some explanation. I'll wait. Ooh, problem 3, we're adding another step. 2 operations. 3 more than twice a number x would be the word phrase. But in math, 3 plus 2x. Done. The 2 operations they're referring to, multiplying 2 times x, adding that to 3. That's why they categorize this differently. They give you a couple more examples. 9 less than the quotient of 6 and a number x. I think I can't emphasize enough how inefficient I think this is. Just use the math. 6x, 6 over x, minus 9. There you go. Much clearer. Letter C, the product of 4 and the sum of a number, x and 7. Oh, I forgot to use my snooty accent. That's all right. 4 times the whole quantity, that's what the parentheses are showing you, x plus 7. Now, show me that you understand what they want. Number 3, label it in your book. Answer A, B, and C. Stop the video, as you should know by now. I'll wait. All right, the next thing logically in your book would be problem 4, but you know what? All you're doing in problem 4 is translating math back into English, and as I said, it's not my favorite thing. So instead, skip it. Moving right along. Turn the page. We're on page 6 now. And let me get the book lined up under the camera. So, problem 5 is wordy, complicated, but one of the more useful things that they have in this chapter. So I would like you to take some time and take a look at it. They are showing you, if you have a house of cards, and if you have to figure out how high off the ground each level is, what you're doing is using algebra. If you want to figure out how high off the ground the second level is, well, if each level is 3.5 inches, you have to multiply that times 2. You have to add the 24 inches that counts for the leg of the table. If you do this enough times, you create a pattern. The third level will be 3.5 times 3 plus 24. The fourth level, 3.5 times 4, and so on. What they want you to be able to do is develop a rule, a mathematical expression, or an algebraic expression for n levels. How do you figure it out? The rule in words: multiply the number of levels by 3.5 and add 24. As an algebraic expression, you have 3.5n plus 24. Now, like I said, this is an important and useful concept. So if what I just did doesn't make much sense to you, pause the video, take a look at it, think it through, and then start the video again. Once you are comfortable with the example they give you, take a look at number 5. Ironically, I've actually seen questions like this on the SAT. Ooh. So this is actual useful math in spite of the fact that it was on the SAT. Given that you're drawing line segments to vertices, they want you to develop a rule as an algebraic expression to show how you figure out how many triangles are made. This particular polygon, 1, 2, 3, 4 triangles. I would strongly recommend drawing a few more polygons on your own so you can play with this rule a little bit and figure it out. Here is one with 1, 2, 3 triangles. Here is another one with 1, 2, 3, 4 triangles. Here's one with 1, 2, 3, 4, 5 triangles. Once you've figured out the pattern, this chart is going to help you with the pattern, you should be able to create an algebraic expression. You go ahead and work on that. Last but not least, I'm at the top of page 7 right now. I would like you to do the exercises in this lesson check 1 through 8. You can skip number 7. It's vocabulary, and we've already talked about that at the beginning of your homework. Okay? Do all the others and do each one, ABC, ABCD. Okay? We will go over this first thing tomorrow. Good job!